Welcome to Preeminent Test Prep. Today is day 39 in our 90-day SAT Prep series. Today we're going to be spending about 20 to 25 minutes with the math section and then right around 20 to 25 minutes with the reading section. Okay, so for today with the math section, we're going to be going from SAT Practice Test 1. We'll be doing problems 31 through 38 of the Math with Calculator section. I'll be really trying to give you my tips, tricks, advice, and strategies for the SAT Math section. Today, in particular, will be about the Math with Calculator free response section. That's really what we're going to be diving into today, giving you all my advice there. Then after that, we're going to switch over to the SAT writing section, where I'll give you my tips, tricks, advice, and strategies for that as well. So keep in mind that I am an back-to-back 800 scorer with the SAT Math section. So I'm really going to try to give you insight into what I look for when I take it, what I can do to save time, and how I can help you save time and be more efficient with this section. So it would be helpful to have a notebook out, also a workbook out, so you can write down problems and get practice doing that as well. So with that, let's go ahead and get started, and also make sure to like, subscribe, and share. But let's go ahead and get started with problem 31. So we have why it can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 ears of corn? Okay, in situations where I have a possible range that I can pick from, in this case it's 12 to 18, right, dozen ears of corn. Now keep in mind 12 and 18 are included in that because it's at least 12 and at most 18. So I have those rates, right? In total, I need to husk 72 dozen ears of corn, right? Now, what I'm going to do here is I'm going to look to pick one of 18 or 12. Now, why is that? Well, I'm going to pick 12 in this case. Okay, I'm going to pick to divide by 12 because we need a total of 72. Dividing by 12 per hour will get me my total in hours. Now, why do I pick 12? Well, I pick 12 because I see 72 and I think 12 times 6 is going to give me 72, right? So I know my answer there is going to be 6. Okay, so 31, answer there is going to be 6, but here's the big question is why am I picking 12? Okay, I want you to get to understand that. When I see I have 72, immediately I want to think between this 12 and this 18, okay? Because if I pick a number in the middle, it might not divide well and I could be left with a fraction or a decimal. And I don't want to deal with fractions and decimals because that's really just not gonna work well, okay? If I have to plug in a decimal here, that's just wasting time and I don't want to do that. So what I'm going to look to do is if I see 72, I'm just going to look at 12 and 18 and think which one of those is a factor of 72. That way I can get to an even answer, okay? So I immediately think 72 over 12, I know that that's 6, so that's why I picked to divide by 12. And that's why I'd recommend you pick, in this case, to divide by 12 as well. So in this case, my answer there would be 6. Keep in mind that any number between 4 and 6 would be correct. So anything from 4 to 6 would be correct. But in this case, I thought that dividing by 12 would be the easiest and quickest way. And I still do believe that because also then you only have to fill in one number. So that makes it easy in that sense as well. Now, let's say you struggle with word problems. How could you do this if you struggle with word problems and didn't immediately recognize that? Well, I'm going to explain that as well. So let's say that we have 72 dozen ears of corn, which I'm just going to call 72 corn because we're dealing in dozens of ears and everything, so it won't really matter if we leave that out. So we got 72 corn. We want to know how long it's going to take us to husk it, right? So what we're going to want to do then is take that 72 ears of corn and we're going to want to divide it by our rate, okay? So we have 72 ears of corn divided by it taking us 12, it says 12 corn per hour, 12 corn per hour, okay? Because we can husk 12, what is it called? Husking 12 dozen ears of corn per hour, right? So now we can rewrite that, and we can rewrite that as 72 corn multiplied then by 1 over 12 things of corn per hour. Okay, now what we see is that corn is going to cancel there. Okay, and we'll be left with 72 over 12, which is 6, and that'll be 6 hours. Okay, so if you struggle with word problems like these, what you can do is you can cancel your units to make sure you're doing them correctly, right? So in this case, I had 72 things of corn. I'm dividing them by 12 things of corn that I'm doing per hour. My corns are going to cancel there, and we see that I'm left with hours. Okay, so that's a way that you can check your work. Okay, so my answer there is 6, and that's how I check my work in that scenario. Now keep in mind, I'm not going to check my work just to check it, right? Once I get my answer, I'm going to move on because I want to make sure I answer every question. Now, once I've answered everything and I feel confident in my answers, then I can go back and check my work. But I wouldn't check it just to check it. But if you're not sure where to start, then that's a good way to find where to start, is to work by canceling units. So if you don't really know right away that you got to do 72 over 12, then go ahead and work on canceling units because that's a good way to start if you don't know where to start. 32, the posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. If the combined weight of the empty box delivery truck and the empty delivery truck and its driver is 4,500 pounds, what's the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted weight limit? All right, well, we know that we're going to have 4,500 pounds as the weight of the driver and his truck, and we know that we can have a maximum of 6,000 pounds on the bridge. Okay, we know that we have 14 pounds for every box, which is X. Okay, so our equation then is going to be that our total weight, which is that 14 times every box plus 4,500, has to be less than that 6,000. So we have to solve for our maximum X, so we're going to subtract 4,500 from each side. 6,000 minus 4,500 is going to leave us with 1,500. That has to be greater than or equal to 14X. Since we know we're solving for the maximum, we want it to be equal, so we're going to divide by that 14. We'll do 1,500 over 14, plug it into our calculator. See what we get. That's going to give us 107.14. Keep in mind we can't have 0.14 of a box, and we also have to round down because it has to be less than that weight. But really it's just because we can't have 0.14 of a box. Therefore X then must equal 107. Okay, 107 must equal X because that's what that equaled, 107. So our answer there, 107, is going to be our number of boxes. So as far as tips for this type of question is an inequality question. So we just set that 6,000 pounds. We know that we can't have anything more than that or that bridge is going to collapse. So we're going to have to set that. We got 14 pounds per box, so that's going to be 14X, and then we add that initial weight of that box and that truck and its driver, okay, to get that total weight. So we set the total weight equal to the maximum we can have on the bridge, and then we solve for X. So that one right there is not too difficult. Okay, now we got 33. The number of portable media players sold worldwide each year from 2006 to 2011. I got my numbers sold millions on my y-axis, year on my x-axis. According to the line graph above, the number of portable media players sold in 2008 is what fraction of those sold in 2011? Well, I'm going to go from 2008 up to my line. Now keep in mind this is a strategy I use with the SAT math section, is drawing lines, okay, to make sure I don't mess up visually. So we got that at 100 is 2008. And what fraction is that of those sold in 2011? Okay, I draw a line from 2011 up. Then I go over to my y-axis, that's 160. So my fraction sold in 2008 over those sold in 2011, I'm going to go like this then, that 2008 over 2011, right? I want that data. Keep in mind this isn't my answer, that's just my years. So my data then is going to be that 100 over that 160. Okay, I see my zeros can cancel there, so I'll have 10 over 16. Keep in mind I can't put that in my bubble sheet because there's not enough room, so I got to simplify. When I simplify, I divide 10 by 2, that's 5. Divide 16 by 2, that's 8. So my answer there is going to be 5 over 8. So as far as things to know for this one, like I said, drawing those lines, and then after that, just writing that ratio, and then you get the answer 5 over 8. So that one, not too bad at all. All right, 34. A local television station sells time slots in 30-minute intervals. If the station operates 24 hours a day, every day of the week, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? Okay, Tuesday and Wednesday is 2 days, so I've got 2 days times 24 hours per day. I see my days will cancel. Now at that point, I have my units in hours. I know that I have 30-minute intervals is what each advertising time slot can be. I know 30 minutes is 1/2 of an hour. Okay, so I've got 1/2 of an hour is what each 30-minute interval is. And if I have one time slot per every half hour, that means I have 2 time slots per every hour then, right? So now I got to multiply that by 2 time slots, which I'll call TS per hour. So now my hours cancel, and I'm left with the number of time slots that that station can have for Tuesday and Wednesday. So 2 times 24 is 48, times 2 again, that's going to be 96 as my total answer. Okay, once again, you see how I'm using units to cancel. I see I end in the units time slots, which is what my answer needs to be. Okay, so that's how we can use units to make sure we're getting to our final answer correctly. That's also how we can make sure we're checking our work as we go. So I talked about how we don't necessarily want to just check it to check it, right? We want to make sure we finish all of our problems before we check things, but we can always check it as we go, right? This is a perfectly fine thing to do to make sure you're checking it as you go by using those canceling of units. That's something that I personally would do on some problems. I might not do it on all of them just because sometimes I can immediately see the the problem I have to do, and I feel like writing down those units is going to waste time. But in certain situations where you have a couple of units you have to convert, it can be very helpful to make sure you're staying on track and that you're using the right ratios of things. So in this case, I would use it here, okay? Because it's an easy way to make sure you're following the correct path and getting to the correct answer without having to go back and check your work afterwards then, because you know that you have checked it pretty much as you went by converting those units, right? So answer there is going to be 96. All right, now we've got question 35. So let's go ahead and get down there. Question 35. Okay, I see I've got a cylinder. So a dairy farm is using a storage silo that's in the shape of a right circular cylinder above. If the volume of the silo is 72 pi cubic yards, what is the diameter of the base of the cylinder in yards? All right, one thing I want to point out here, you're given the equation for volume of a right circular cylinder on the SAT math section, but if you memorize it, it's going to save you a lot of time. Okay, so the equation for volume is going to be pi r squared times your height. Now, if you have to flip all the way back from question 36, you're going to have to flip a few pages, and that's probably going to take you at least 30, 40 seconds to do. So that's a waste of time. We want to make sure we have those equations that are given to us on the SAT math section memorized so that we save that time, okay? All right, so we know our volume is going to be pi r squared times our height. Now we know that our height is 8 yards, so we can go ahead and substitute that in. We know our volume is 72 pi, okay? So we're asked to solve for the diameter. So in order to get to the diameter, we're going to solve for the radius and then double it. So we're going to go ahead and divide each side by 8 pi, get rid of that, okay? Get rid of our 8, get rid of our pi, divide by 8 pi over here. Our pi is going to cancel. We have 72 over 8, which I know is equal to 9. So now I have 9 equals r squared. I go ahead and square root each side. The square root of 9 is going to give me 3. Square root of r squared is going to give me r. So 3 is my radius. Therefore, my diameter has to be 6 because 2 times my radius gives me my diameter. Okay, so I'd take my radius. R times 2 equals d. Radius is 3. 3 times 2 gives me 6. So my answer there is going to be 6 for my diameter. All right, so now we've got, as far as things I just want to cover on this one that you could put in your notes, understanding we want to make sure we memorize those equations that are given to us. That's the first thing. Next thing, just making sure that we're canceling things, right? We don't want to be dealing with pi when we don't need to, so we cancel it out. And yeah, this one really is not too bad either. So that one's just understanding your equations and solving. So that one's really just geometry. 36, okay, this one right here. For what value of x is the function h above undefined? All right, in order for a function to be undefined, its denominator, so that thing below that division sign, it has to equal 0. Okay, so I'm going to set that equal to 0, and then I'm going to solve for what x is when that's equal to 0. So the first thing I'm going to look at is this x minus 5 squared. Okay, that means I'm going to have x squared minus 10x, because this minus 5 right here is going to get multiplied by x once, and then again because x minus 5 squared can be rewritten as this, x minus 5 times x minus 5. We have minus 5x there, minus 5x there, that's minus 10x. Next thing we're going to have minus 5 times minus 5 gives me positive 25. Okay, next I have plus 4x, so I'll add 4x right here. And then I'm going to have a plus 4 times a minus 5, which is a minus 20, so I'm going to subtract 20 there. And then I've got plus 4 right here, so I'll just go ahead and put my plus 4 here as well. Okay, I set that equal to 0. So let's go ahead and see what this simplifies down to. Well, we have an x squared that drops down, so we got x squared, and then we have negative 10x plus 4x. Negative 10x plus 4x is going to leave us with a minus 6x. And then we have positive 25 minus 20. That gives us positive 5. Positive 5 plus 4 gives us positive 9. We set that equal to 0. At this point, we factor out, okay? So we're going to factor this. And then whatever its x-intercepts are from this factoring is going to be our answers, right? So we're going to have x squared minus 6x plus 9. So that means I'm looking for factors of 9. What times what gives me 9? That adds to negative 6. Well, that's going to be negative 3 times negative 3. Okay, negative 3 times negative 3 gives me 9. And negative 3x plus negative 3x gives me minus 6x. Okay, so my answer there then is going to be that x equals 3, right? Because I take this right here and I flip its sign to find what x is going to equal, right? And here's why that works, because we'd set x minus 3 then equal to 0, and then we'd add 3 to each side, add 3 to each side, and we'd see that then 3 equals x, okay? So our answer there is going to be 3. 3 is the value of x that makes it undefined. So important things to recognize here is that in order for a function to be undefined, that denominator's got to equal 0. Then after that, we just make sure that we go ahead and take all of the steps, right, to find and simplify our denominator. We simplify our denominator, and then we go ahead and factor it out and solve for what our x-intercepts are, which is where it equals 0, and that's going to be at 3. So 3 is our answer for 36. So that one right there, that one is definitely worthy of the number 36 spot in my opinion. I'd say that that one's a little bit of a more difficult question. So I would definitely say that that's worthy of the 36 spot on the SAT math section. All right, now we got questions 37 and 38. So we have Jessica opening a bank account that earns 2% interest compounded annually. Her initial deposit's $100 and she uses the expression 100 times x raised to the power of t to find the value of the account after t years. Keep in mind that this is our interest equation that we talked about in week 1. Okay, that's our interest equation. What's the value of x in the expression? Well, the value of x is going to be that 2% interest plus her initial, it's the 2% interest plus 1, right? So she's gaining 2% on whatever amount she had in, which means we have to multiply that by 1.02, right? It's 2% in addition to what was already in there, right? So it's going to be 1.02 because it's what she has in there, it's staying in there, right? So it's going to be 1.02 is going to be our answer for 37. Okay, so if we have 2% interest, it means that we are multiplying for this x by 1.02 because that's that 2%. So 37 answers 1.02. That one right there is very, very simple. That one's really kind of a lead up to question 38. I'd imagine question 38 is going to be the more difficult one. So we have Jessica's friend Tayshawn opens an account that earns 2.5% interest compounded annually. So once again, we're going to have that same equation, except we are going to have, it says his initial deposit's $100 as well. So his would be 100 times 1.025 since he's earning 2.5% interest. Okay, and then that's going to be raised to the power of t as well. Into his account at the same time Jessica made her deposit of $100 into her account. Okay, we know she's earning 2% interest, so hers will be 1.02 to raise to the t. After 10 years, it says, and I'll erase so you can see it better. After 10 years, how much more money, okay, so the difference between the two, will Tayshawn's initial deposit have earned than Jessica's initial deposit? Round your answer to the nearest cent. Ignore the dollar sign, obviously, because we can't enter a dollar sign. Okay, so we're looking for the difference, so we're just going to subtract one from the other, find our difference, okay? In this case, we're going to go ahead and plug it into our calculator. That's pretty much exactly what I'd plug into my calculator. Keep in mind, t, it says, is 10 years. So this is raised to the power of 10 and raised to the power of 10. So we plug this into our calculator. We got 100 times 1.025 raised to the 10th. And then we subtract 100 times 1.02 raised to the 10th. And that gives me 6.109. Now I'm asked to round to the nearest cent. Since this is a 9, that means that this becomes a 1. Okay? So let's see if this will erase. There we go. Okay, that becomes a 1. So our answer there is going to be 6.11. So $6.11 will be the difference there. So as far as things to note for this question, we're asked for the difference, so we're going to subtract our smaller one from our bigger one, right? We know that this one's going to be bigger because it's that 1.025, so they're gaining more interest, so they're going to have more money. So that's how we're going to find the difference there. Important things to pay attention to are the interest rates, the initial deposit values, and the t years, okay? So those are the important things to pay attention to there. That's really all that I wanted to cover today. I've already covered a lot of stuff on this free response section for the math with calculator. So with that, let's just go ahead and switch over to our other section. It sounds like today is probably going to be a bit of a shorter day, definitely not an hour for today. All right, let's get started with our reading section for today. So once again, today we'll be doing our last passage from SAT Practice Test 6. So we're going to be going through passage 5. So passage 5 here is a science section. So basically what I'm going to be doing is I'm going to be breaking down how I approach science passages, how I approach individual passages like this where they're not paired with a second passage, breaking down what I go through as I do my initial read through, why I highlight certain things. Okay, keep in mind you'll be underlining them since you can't highlight on the SAT. And then after that, I'll get into my questions. So I'll go through question types, so that'll help you determine your strategy for each question by really understanding what it's asking you to do. Then as I go through those question types, I'll be telling you why correct answer choices are correct, why incorrect answer choices are incorrect, and how we can make that difference, right? How can we determine which ones are correct, which ones are incorrect, and really show you how ruthless we have to be and how answer choices that are incorrect, one word will make it incorrect. So really breaking down what I see as I go through SAT reading sections as a 1590 SAT score is what we'll be doing here. So with that, let's go ahead and get started. So we got this passage adopted from Kevin Bullis, What Technology is Next for the Solar Industry, written in 2013, or copyright 2013, and it was published in MIT Technology Review. All right, so let's go ahead and get started reading. Solar panel installations continue to grow quickly, but the solar panel manufacturing industry is in the doldrums because supply far exceeds demand. The poor market may be slowing innovation, but advances continue. Judging by the mood at this week's at the IEEE Photovoltaics Specialist Conference in Tampa, Florida, people in the industry remain optimistic about long-term prospects for solar. The technology that surprised almost everyone is conventional crystalline silicone. A few years ago, silicone solar panels cost $4 per watt, and Martin Green, professor at the University of New South Wales and one of the leading silicon solar panel researchers, declared that they never go below $1 a watt. Now it's down to something like 50 cents a watt, and there's talk of it hitting 30 cents per watt. The U.S. Department of Energy has set a goal of reaching less than $1 a watt, not just for the solar panels, but for complete installed systems by 2020. Green thinks the solar industry will hit that target even sooner than that. If so, that would bring the direct cost of solar panel to 6 cents per kilowatt hour, which is cheaper than the average cost expected for power from new natural gas power plants. All parts of the silicon solar panel industry have been looking for new ways to cut costs and improve the power output of solar panels, and that's led to steady cost reductions. Green points to something as mundane as the paste used to screen print some of the features on solar panels. Green's lab built a solar cell in the 1990s that set a record efficiency for silicon solar cells, a record that stands to this day. To achieve this record, he had to use expensive lithography techniques to make fine wires for collecting current from the solar cell. But gradual improvements have made it possible to use screen printing to produce even finer lines. Recent research suggests that screen printing techniques can produce lines as thin as 30 micrometers, about the width of the lines Green used for his record solar cells, but at costs far lower than his lithography techniques. Meanwhile, researchers at the National Renewable Energy Laboratory have made flexible solar cells on a new type of glass from Corning called willow glass, which is thin and can be rolled up. This type of solar cell they made is the only current challenger to silicon in terms of large-scale production. Thin film, cadmium, telluride. Flexible solar cells could lower the cost of installing solar cells, making solar power cheaper. One of Green's former students and colleagues, Genoa Zhao, co-founder of solar panel manufacturer China Sunergy, announced this week that he is building a pilot manufacturing line for a two-sided solar cell that can absorb light from both the front and back. The basic idea, which isn't new, is that during some parts of the day, sunlight falls on the land between the rows of solar panels and a solar power plant. That light reflects onto the back of the panels and could be harvested to increase the power output. This works particularly well when the solar panels are built on sand, which is highly reflective. Where a one-sided solar panel might generate 340 watts, a two-sided one might generate up to 400 watts. He expects the panel to generate 10 to 20% more electricity over the course of a year. Even longer term, Green is betting on silicon, aiming to take advantage of huge reductions in cost already seen with the technology. He hopes to greatly increase the efficiency of silicon solar panels by combining silicon with one or two other semiconductors, each selected to efficiently convert a part of the solar spectrum that silicon doesn't convert efficiently. Adding one semiconductor could boost efficiencies from 20 to 25% range to around 40%. Adding another could make efficiencies as high as 50% feasible, which would cut in half the number of solar panels needed for a given installation. The challenge is to produce good connections between these semiconductors, something made challenging by the arrangement of silicon atoms in crystalline silicon. All right, so let's go through why I highlighted the things that I highlighted real quick. So I'm going to switch over to my pen, and then I'll cover that. So as always with that intro, right, I'm always going to make sure that I'm highlighting my copyright year, my title, my author, and any time for the science section in particular, it will sometimes give when it was published in. So in this case, it was published in the MIT Tech Review, and I'll always make sure I highlight that as well. Keep in mind, any time that I say highlight, that's the thing you should underline because you can't use a highlighter. All right, next we have this. Solar panel manufacturing industry. We see that there's supply that exceeds the demand, right? So there's less demand for solar than there is supply. So that was a claim that I highlighted. So anytime I have a claim in a science section, I'm going to make sure I highlight that. Next, we have the poor market may be slowing innovation, but advances continue. That's also a claim, okay? Poor market is slowing innovation, but advances are continuing. That's another claim. The next thing we have, people in the industry remain optimistic about long-term prospects. Okay, once again, that's a claim. Always making sure I highlight claims, especially on the science section. Down here, we have all parts of the silicon solar panel industry have been looking for ways to cut costs and improve the power output of solar panels, and that's led to steady cost reductions. Okay, so this is two things. There's two reasons that I highlighted this. Okay, one is that it is a claim, okay, saying that they're trying to cut costs and improve the power output of solar panels. The other thing is that it's giving me a problem and a proposed solution, right? It's telling me the problem is that things are too expensive right now and they don't produce enough power, and it's telling me that they're working on that, okay? So anytime I can identify a problem in the science section, I want to make sure I highlight that, okay? So science sections, anytime I see a problem, I want to highlight that. And anytime I see a solution, I also want to highlight that as well. Next, we have down here, okay, the lines Green used for his record solar cells are now being printed using screen printing, but at costs far lower than his lithography techniques. Okay, so like I said before, in our previous thing I highlighted, that was a problem. It's too expensive and doesn't produce enough power. Down here we have a solution. Okay, these screen printing techniques are producing these record solar cells at costs that are much, much less than that record-breaking solar cell. Okay, so we're seeing a decrease in cost here by using the screen printing technique. So that's a solution. I want to highlight that. All right, up here, the type of solar cell they made is the only current challenger to silicon in terms of large-scale production. Okay, I talked about this before, and I'm going to say it again. Anytime I see something like the only, or only one, or best of all, or anything like that that indicates that there's only one other thing in something, or something's the best or the worst, I always want to highlight that. So that's why I highlighted that there, because it's the only current challenger. Okay. Okay, next we have flexible solar cells could lower the cost of installing solar cells. Okay, once again, providing a solution to that problem, because we're lowering the cost, thus making solar power cheaper. So that's a solution. That's why I highlighted that. Next, we have that light reflects back onto the panels and could be harvested to increase power output. Okay, increasing that power output, also providing me a solution to my problem. So I highlighted that as well. Even longer term, green is betting on silicon, aiming to take advantage of huge reductions in cost already seen with this technology. Okay, that's telling me that silicon is providing cost reductions. So once again, showing me my solution is going to be silicon based more than likely, according to green. All right, and then that takes us through there. Okay, so with that, we've got our our two graphs. Now we can go ahead and get into our questions. Okay, so this passage is written from the point of view of a what? All right, well, if we really think about what this passage is coming from, right, it was written in the MIT Technology Review, and we know that it's really coming from not a scientist himself who's comparing different research methods, because we're not comparing research methods. We're describing a research from a journalist, pretty much, right? We have a journalist who is enumerating these changes in this field of solar, right? The field of solar used to be very expensive and not have enough power output. Now we're seeing changes or advances in technology that are lowering those costs. So he's really acting as a journalist who's talking about these changes in that solar industry. Okay, it's not a scientist competing or comparing competing research methods, because we don't have competing research methods. As far as a consumer, definitely not written from the perspective of a consumer. B, a hobbyist explaining the capabilities of new technology. No, definitely not a hobbyist either. Okay, this is pretty formal. This would be a journalist who is enumerating the changes in a field. So C would be our answer for 43. As far as for what type of question this one is, this one's kind of tough to place. It's not really a super common question. This one's really kind of a rarity on the SAT reading section. It doesn't necessarily fall into one type. It's really a perspective question, asking you pretty much the perspective of who's writing it, right? So that's really what that is. There's not really a common question type for that one. As used in line 4, poor most nearly means. Obviously, this is a words in context question because it's asking the most nearly means. So line 4, poor, what does it most nearly mean? Let's go take a look. Come up with our own answer choice first. That way we're not swayed by two. We've got the poor market may be slowing innovation, but advances continue. Okay, when we say a poor market, we don't necessarily mean financially it's poor, right? Now, financially, obviously, it is weak, but we're not really saying poor in the sense that it's like, something that is lacking necessarily funding. It has funding, but it's a weak market, right? We say that there's not much demand. Okay, if we have a poor market and we say that there's supply exceeding demand, what we really mean by that is it's a weak market, okay? Because there's not much demand, demand is weak. So we would characterize that then as a weak market, would really be the best answer choice there, okay? So let's see if we have anything that says that. We do have weak, so weak would be our answer there. So 44 should be A. As far as why B, C, and D are wrong, let's cover that. Would we say a humble market? No. Humble would be used to describe a person, not a market. A pitiable market? No, we can't pity a market. Obsolete market? No, it's not obsolete because there is still some demand. It's just weak demand. Okay, it's a weak market, not obsolete, because the market's still there. It's just weak. All right, 45. It can be most reasonably inferred from the passage that many people in the solar industry believe what? Okay, this is obviously an inference question. The tell here is that it says the word inferred, so it's obviously an inference question. Many people in the solar industry believe what? Well, the people in the solar industry, what they're really believing, and we'll actually just run through A through D a minute, and I'll just go ahead and show you why the correct answers are correct, why incorrect answers are wrong, just to make it easier for you to see how I would do this if I were going A through D. So A, consumers don't understand how solar panels work. We never make that claim, so that's wrong. B, two-sided cells have weaknesses that have not yet been discovered. Once again, we never make that claim. Okay, we are actually arguing for the advancement of these two-sided cells because we say that they're strong. We don't mention any weaknesses that haven't been discovered. C, the cost of solar panels is too high and their power output too low. Yes, we do make that claim, right? We say that many people believe that. We talk about it from at that conference when they talk about how solar panel costs are currently too high, power output too low. I'm guessing we'll probably have an evidence question after this, in which case I'll go ahead and show you the evidence for it. D, willow glass is too inefficient to be marketable. This is too narrow. Too narrow. Okay. Also, I don't think we ever say that it's inefficient to be marketable either, so it's also false. All right, so C is going to be our answer for 45. Let's see if we have evidence. I see what we do. Okay, so evidence for the cost of solar panels being too high and their power output too low. I do believe I highlighted that already. So let me go ahead and find where I said that. Right here, where we talk about all parts of the silicon solar panel industry have been looking for ways to cut costs and improve the power output of solar panels, and that's led to steady cost reductions. Okay, so I see that that's going to be from 27 then to 30 would really be my best answer choice there, possibly 27 to 29, but really looking at 27 to 30. And I see I do have 27 to 30, so that'll be my answer there. So I'll have answer choice D for 46. All right, 47. 46 is obviously an evidence question, right, because we're just providing evidence. So now we got 47. According to the passage, two-sided solar panels will raise efficiency by doing what? Well, in the passage, we talk about them raising efficiency by absorbing that reflective light, right? We talk about how light will hit one, some of it will bounce off, so that doesn't get absorbed. But then when it hits the other one, then it's absorbing that reflective light, so therefore we're capturing more of that sunlight energy, okay? We never say they're going to require little energy to operate, and even if they did, we never say that that's going to raise our efficiency. C, being reasonably inexpensive to manufacture, we never say that. Also, once again, if it was inexpensive to manufacture, that's not going to raise efficiency. That's a key part here. We're talking about raising efficiency. How's it going to do that? Well, requiring little energy to operate, that's not going to raise the efficiency of the solar panel. That would lower our costs, but it's not going to raise efficiency of the solar panel. Neither would being inexpensive to manufacture. D, preventing light from reaching the ground. No. Okay, the whole point here is that they form those two-sided ones to absorb that reflective light that reflects off of one. So 47 there, answer is going to be B. We're asked for evidence, so we can go back and find that one. I believe that's right around mid to low 60s. Where yep, right here. I highlighted this as well. It was a solution. As you can see, highlighting solutions and highlighting problems and highlighting claims, you can see that it really helps you when you have to go back and find evidence as well, because you kind of already have it there. So we have in this case that light reflects back onto the panels and could be harvested to increase power output. Okay, so that's going to be 61 to 62 is what I'm looking at in my answer there. Okay, so highlighting those solutions, in my opinion, is really important, because if you highlight those solutions and then you're asked to find it for evidence, you pretty much already have it, and you don't have to run through all of these lines. You know it's going to be 61 to 62. So 48 there, our answer is going to be B. Now we've got 49, so we're actually moving pretty quick through this today. So 48, obviously an evidence question. I did forget to do a question type for 47, so I'm going to quick cover that. As far as two-sided solar panels, how they're raising efficiency, this is a little detailed question. You had to go back, find that detail in line 61 to 62. So that's really all that was. Question 49 now. Obviously, once again, words in context question, because it says most nearly means. We're asked for what betting on means in line 69, so we can just go there, take a look at it, see what our own answer choice is going to be. So I think it was line 69, I believe. Yep. So even longer term, green is betting on silicon, aiming to take advantage of the huge reductions in costs already seen with this technology. Okay, in this case, what does betting on mean? Well, he's not gambling on silicon. Okay, that's wrong. What he is doing is he is pretty much counting on silicon, or he's pretty much pursuing that as his goal for lowering that cost of solar, right? We would say he's counting on silicon. We could say he is relying on silicon. Either of those would be possible answer choices. I don't know if either of those were given to us when I recall what we had as our options, but we can try to find something similar. Okay, so if we look at our options here for 49, we see that we do not have counting on, right? And counting on wasn't too strong. That one, it was kind of tough to come up with our own answer there, but it definitely wasn't gambling with. I explicitly said that. As far as dabbling in, he's not dabbling in it. He's really counting on it heavily, so it's definitely not a dabble. It's him counting on it heavily. He's not switching from it, but he is optimistic about it, okay? He's optimistic about it. He wants to rely on it, count on it. That's our best answer choice there. That will be our correct answer choice there. So 49 will be D. All right, question 50, we got the last sentence of the passage mainly serves to do what? Anytime we got mainly serves to do or purpose, that's going to be a purpose question. Okay, so we got purpose question here. Last sentence of the passage serves to do what? Let's go take a look at it and see what we think. So we've got last sentence of our passage. I don't recall exactly what it said, so we'll take a look at it. We've got the challenge. Okay, so we're describing a challenge right now for solar industry, is to produce good connections between these semiconductors, something made challenging by the arrangement of silicon atoms in crystalline silicon. Okay, so we're describing a challenge that still has to be overcome in the solar industry is what I got from that. So let's see if we have an answer choice that says that. So let's run through A through D. We have option A, express concern about limitations of a material. No, we're not expressing concerns over limitations of a material. What we're really doing is identifying a hurdle that must be overcome. So B will be our correct answer for 50. Like I said, we talked about how there was that difficulty, and I'll just quick run back and show you so you can just see it again in more detail since we're running way ahead of time on this passage anyways. So we have the challenge is to produce, okay, so a challenge or a hurdle, like we said in B, is to produce good connections between these semiconductors, something made challenging by the arrangement of silicon atoms in crystalline silicon. Okay, once again, just one thing I want to point out as to why A was wrong. We're talking about the arrangement of those atoms, and we see that in A. Let me find it. We see in A, we say the limitations of a material, and well, it's really more the limitations of the arrangement of the material, right? But also, really, that's not, the key part here is mainly serves, right? What's the main serve, okay? This is really too narrow. That's focusing too much on that part where we talk about that material itself. Really, the main purpose of it is to show that hurdle we have to overcome in that solar industry, okay? So we really don't want to get too narrow here. Option A would be too narrow. And then as far as option C and D, making a prediction about the effective use of certain devices, we don't do that, or introduce a new area of study. Both of those are just factually incorrect. Okay, we're identifying that hurdle or that obstacle that needs to be overcome in that solar industry. 51, according to figure 1 in 2017, the cost of which of the following fuels, so we got 2017 in figure 1, which of the following fuels is closest to the 2009 average U.S. Energy cost in figure 2. So we go to figure 2, let's find that cost, and then bring it over and look at which material has that same cost. We see that our 2009 U.S. average energy is 120 kilowatts per hour. So we go find that in this figure 1. We're going to draw a line up from 120, find what's closest to it. We see that that's advanced nuclear. Okay, so our answer there would be advanced nuclear. That's obviously a data interpretation question. Okay, obviously it's interpreting that data, so advanced nuclear, D will be our correct answer for 51. All right, 52. According to figure 2, in which year is the average cost of solar photovoltaic power projected to be equal to the 2009 U.S. average energy cost? Well, let's go ahead and scroll up. We've got our 2009 average energy cost. We're looking for where it intersects this line of that projected average cost for those photovoltaic cost per megawatt hour. We see that they intersect at 2020, so 2020 will be our correct answer there. So we go down, we see that that's going to be answer choice B for number 52. Okay, once again, that's a data interpretation question. So 52 there will be B. Let's just run through, make sure we answered all of them. I believe that we did. Let's take a quick look. And it looks like we did answer all of them. All right, so as always, as far as with the science section, I'll just touch on a few things since we got plenty of time here. As far as the science sections, I really want to point out how important it was to make sure that we paid attention to highlighting our solutions and our problems, okay? For the science sections especially, if you have something where you're talking about problems and solutions, always make sure that you're highlighting or underlining those problems and those solutions, okay? Once again, you can't use a highlighter on the SAT, you'll be using a pen, or I'm sorry, you'll be using a pencil, so make sure you're underlining those things, okay? So problems and solutions on the science section is very important to pay attention to those. That's very, very important. Also, as always, any claims we make, want to make sure we pay attention to those as well, because those give us our direction of the passage, okay? So that's really the big thing with those science sections. Just another thing that I always pay attention to is just where it's published, because that can give me a good idea of kind of what the goal is of the passage and things like that, as well as we were asked about the author's point of view here. That can kind of tell me it's going to be from a journalist if it's written in MIT Technology Review. Keep in mind, it also could have been a scientist, but the reason the part that said a scientist was wrong was because it's talked about comparing research methods, and we didn't compare any research methods. So if I saw MIT Technology Review, I'd be looking at it as possibly a scientist or a researcher or possibly even a journalist, okay? In this case, the reason scientist was wrong was because it referred to two different research methods being compared, which did not occur. All right, so as always, thank you for watching. Make sure to like, share, and subscribe. If this is helpful to you, there'll be a donation link in the description when it's up and running. Any private SAT tutoring I'm doing will be linked in the description. Any private college admissions consulting I'm doing will be linked in the description. Make sure to have a good day and goodbye.